Hi, welcome to Grid Down Preparedness. My name's Wade. If you've been following my journey with these two Pecaron portable power stations, you know what's up. If not, you're in for a treat. So please be sure to like and subscribe for the channel. Also, check out about joining the channel and becoming a channel member so I can bring more exciting content to you guys. Thank you to my channel members. So much for your continuing support. So anyway, let's get into the video. So I posted a video a couple of days ago, and then I posted one this morning about this power station here. This one had an inverter output short circuit. And I did the testing steps that the manufacturer recommended, which was unplug the network cable, connect the 240 voltage hub, check the error messages, take a photo, record the watts between L1 and L2. Well, I went a little bit crazy and I was measuring everything. And I'm not an expert on 120 volt systems or anything like that, but I did learn something thanks to one of the viewers. So I was mistaken when I said that this was the neutral. This plug over here is actually the neutral, so the T-shaped one, and this one here is actually the line. So I was mistaken there. So anyway, to recap, I did one test, and I still had the inverter outlet short circuit. I came in, I reread the email, and I said, oh man, I forgot to take pictures. So I came back out, I set the whole table and test up again because I already moved this power station back to here and put that one back on top of my cooler over there, getting ready to box it up, expecting that they're gonna send me a ticket to ship this thing back. And I said, all right, well, I'm gonna redo the test, I'm gonna set everything back up again, and I'm gonna take my photos. Well, while I was getting ready to take the photos and get the numbers and write them down, this unit decided to start working. I do not know why, but I did hear the relay click on, and I was kind of shocked by that. So what I'm doing right now is I'm discharging this power station back into this power station, and they're both connected to solar right now, and there is absolutely no solar coming in. It's overcast. So what I found really interesting is last night we started out, and I forget what the state of charge was on this unit, but this unit here was going below 50 down to 40. So to test the output, I realized after I filmed the video, I didn't test this thing with a load. I didn't put any load on the system at all. So I ran this fan for like 3 hours, just a low load, just to see, not try to stress out the inverter. I'm getting ready to reconfigure the system and experiment some more. I'm gonna put this in the full stack back the way that I originally had it when I first bought this unit with the 4 expansion batteries. And I'm gonna try something with the bonding cable where I connect just the bonding cable to the last battery in the series over there and see how it stays balanced. So if you already got a permanent setup with your batteries and you can't really move them around, I want to see if I can draw power from this unit through the expansion batteries and keep these relatively balanced. I don't know if it's possible or not, but I am running a test on this right now, drawing the batteries down, and so far it seems to be working. But what was interesting with this system last night is when I got up this morning, I was expecting to find it somewhere maybe around 25% state of charge, and it was completely dead. And the 240 volt hub was connected. It wasn't showing indications of any load. It was just dead. I hit the power button to see if it maybe tripped offline or had that inverter failure message. Nothing. And my battery voltage had dropped down to 46 or so. I took a picture of it. Which I'll actually probably use for the thumbnail for this video. But it seems to be working. I'm pulling power out of here, putting it back in to this battery that I used to charge this one back up from 0 to 100. it made it to 100 and was kind of going between 50 and 100 watts charging. So that battery's fully charged. I'm just charging it back into that one. I don't know if I've got some sort of battery issue, because you can see right now we're at 95% state of charge, 52 volts. This is at 65% state of charge and 54 volts. So I don't know if there's an issue there. One of the things I'm going to do real quick is I'm going to take my multimeter, and we're going to do it right this time. We're going to put the black in to the neutral and the red into the line, and test the voltage under a load. So we're still at 119 where it's supposed to be. So that's fine. Right now there's no AC output on that unit. I'm going to turn on the AC output for pass-through. And it should say UPS mode. And there it is. Okay, so now it's passing through UPS mode. Voltage here is still 119.2, 119.3. We're going to move back over to this power station and plug this into there, and then come into the line, in here. And we are at 118.6. So that's about a volt below that one. And now I'm going to turn off the AC output. And then there's the click. So right now everything seems to be working. It's pulling half a load right now on it. So the only thing I can really think about doing is taking the load off and seeing if the battery voltage, let's see, let's go into this menu real quick while it's under load. Battery health status, battery consistency. So it's showing 92% battery, 52 volts, 37 amps going out, battery temps 89.6. Let's hold this and actually look at the cells and see if we have a dead cell or something that's causing that voltage to be down, or if it's just pulling that much power under a load. Because I don't really know. All right, and try holding it again. And it should go into the menu that shows me the battery cells. So there we are. And it looks like I have a range of 3.23 to 3.25. So these two cells here are below. I've got one that's 326. Okay. I am going to go back here. So we're at 52 volts. Go over to this unit. We're going to go to input-output settings. We're going to go to, nah, that's not the menu I wanted. Input-output, AC charging speed, and we'll drop this back down to 10%. Okay, so that's ramping down. So now this is showing about 210 watts. And did the battery voltage come back up? We're at 52.6. So it looks like it did come up from sitting at 52. So battery voltage is rebounding. Let's swap the charging cord around and see if that draws this other battery pack down. I just want to do a thorough test and see if there's something else that's causing the issue. All right. Okay. Come over here. Might help if I actually turn the output on. Menu, Input output settings, AC charging speed. Gonna ramp that up to 100. All right, so that just clicked. And there we go, it's starting to pull a charge. So battery voltage over here at 68% state of charge, it's starting to drop down with that heavy load on it. And then this has rebounded back to 53.5. So I don't think there's actually an issue. I mean, I'd expect battery voltage to sag under a huge load like that. So, but with the battery percentages and battery voltages being slightly different, I don't understand what's going on there. All right, let's ramp this back down to the 10%. And I do know that Pecron recommends fully discharging and recharging the battery packs every so often, like monthly. So that's been done for this unit and this unit. I've killed them out last month, so they're coming due for this month to do the full charge and discharge cycle. Still 172 out. We're going to unplug that. Take our cable off here. Works if I turn it the right way. And we're going to turn off the output on AC. I'm going to turn the DC output on just so the screen doesn't turn off. And I had a comment about turning the units off. As far as I understand, there is no off. As soon as you plug the solar in, it detects it and it wakes up and comes on. I don't think these actually have an off switch. They're always sleeping if they're not outputting power. So, I don't know. I kind of like an on-off switch, knowing that something's off. Let's reconnect the 240 hub, and we're going to do it just like we did yesterday and the day before in that first test. We're only going to connect the hub, and because I'm going to turn this on, I want to get really quick. I want to make sure that I have what the voltage is actually when this thing turns on. All right, that unit on and this unit on. So right now, this unit has no idea that it's connected to that unit. And then there's our voltage. 233. And you see the voltage drifting. So what that tells me with that voltage dropping and drifting like that, that tells me that the frequency of these two units is slightly different. So one's leading the other and the other's lagging. I know on the ships when I had to synchronize generators, we'd have synchronization lights and stuff like that, and we'd sync by frequency. I'm not monitoring frequency, I'm only monitoring voltage here. But seeing that voltage drop tells me that the amplitude of the waveforms are going down to the null point. And if we keep watching this, eventually at some point this will zero out and start going back up. So we do have a green light on here that says everything is fine, but I think once we get below the 200 volts, it's probably going to start beeping at me. I don't know exactly what that threshold is, but that's why I'm doing this test, because I'm curious and I'd like to share my curiosity with you guys. So we're dropping down the 205. It's starting to fall quick. So if you know anything about sinusoidal waves, once they start falling, they fall fast. Everything's still green. We're going below 200 now. Light is still green. Still dropping down. And there it is. So right at about 193 volts, it's telling me that we got some sort of problem. I have no alarm on either power station at this time. So we're just gonna let this run. There's not gonna be any time lapse or anything on here, and I do apologize for the long video. But please be sure to watch to the end and give me a like and a subscribe. There's an entire playlist at the end of this video that's gonna show all of the testing that I've done on these units since I've had them. So I'd really appreciate you guys if you would check those out if you're interested in these systems. I still think these are good products for what they are. If you need a low-cost, portable power station to take camping and do those types of activities, I think it's good. For my particular situation, losing the ability to pump water at 240 volts is a problem. So I'm still going to keep these units. I'm still going to play with them. I'm still going to use them as my contingency to another system that I'm eventually going to purchase. So we're still dropping down. We're down to the 140s. We've got a flashing red light and a beep. So yeah, the frequency is definitely out of sync on the units. If I go back like I did in the previous test, I go back to these two units, the voltages will still be about 119.7, somewhere in that range. But you can see now we're going to go below the 120. And if my theory is correct, that the waveforms are out of sync because of frequency, we should get down to 2 digits, down to 0, and then come right back up. That's why I want to do this all in one video, so you guys can forward through this section until we get down to the single digits and it coming back up. So we're now at 97 volts. And we're still beeping. And I mean, that's just my theory. This unit here, when I was camping on my camper, it was consistently at 59.9 hertz. This one is 59.9 hertz the last time I looked at it. Not exactly 60. We're down in the 60 volt threshold now, dropping down. So yeah, if you imagine like an AM radio wave, how you have the maximum amplitude from peak to valley, gives you your most power, your most distance, your highest voltages. As it gets back to the 0 line, which these are now intersecting, it's going to reach down to a point. There we go. We hit 0. Oh, no, we didn't. We're still going down. I'm sorry. My cursor on my phone screen actually blocked it. So we're down to 26, 25, 24. It's falling off fast now. And if my hypothesis is correct, we should start going back up after we zero out. And that tells me that the waveforms on here are not in sync whatsoever. 9 volts, 8, 7, 5, 4, 3, and then 1 point volts. And look at that. We're going back up the other way. 6, 7, 8, 9, 10. So without the data cable in, and that's why I call it a data cable, but this is actually the synchronization cable. This, I guess it picks one unit to be the master and the other the slave, to say, all right, this unit here is going to set, what was that? That was a weird beep. Anyway, so you can see the voltage is now climbing back up. it'll probably get back up to 240 and it'll go back down the other direction. So we're gonna power down the power stations. Turn that one off. Turn that one off. And I turned it off fast enough to where I didn't get the error that there was an issue. We are going to plug the sync cable back in. I don't like it being wrapped around those cables. I'm gonna come back here. I'm gonna plug it in. And now we're gonna start this unit. And then we're gonna start this unit. All right. Okay. That's powering up. And there we are. We're synced at 239. It's not rising or falling. So there is between these two power stations, there is a big difference in frequency. Big difference. I want to test one other thing while we're here. We have this in. Let me get my hand out of the camera. All right, so I am going to come out of that line and go to ground. So that is a line to ground, a line to neutral. All right, we're going to come out of that line, and then we're going to go, so we've moved the red probe over. Now this red to ground is 83.6, and then this one is expected 120. So I should have from here to here should be 120, and from here to here should be, here to here is 240, here to here is 120, here to here is 120. And that is indeed 120. That is 240. And that is 154. And then that is 83. So I don't really understand why the voltage here is correct what it's supposed to be. Line 1 to neutral, line 2 to neutral is where it's supposed to be. But line 1 going to ground and line 2 going to ground are different values. And I don't understand why that's the case. If I go to, let me test these outlets, because now that I've been told that apparently this shape outlet is neutral, that's positive, and of course that is ground. Let me see if there's any difference on those, because I didn't really test those in detail. All right, so we're in, that gives me 239.5, and then to there is 84, and then we're going to go over here. That one is 239.5, and then that to ground. So I have basically neutral to ground. There's a voltage. Let me swap these probes around and see what the voltage is here. And then, so from what I think neutral is to ground is 155. Let's do the same thing over here. Come on, get in there. It's a lot easier to do this with two hands, but then you guys can't see what I'm doing. All right, we'll make this work. And then this one here, I don't have a good connection, that's the problem. It's also 145. So, I do not understand that outcome. So maybe I can get the Pecron engineers to comment and explain why that's the case. I was going to hook everything back up, but I was expecting a zero value on this plug. Because if I go back to the 120 side on these, and we use the same concept that this is positive and this is negative, and then I get my 119 volts, and then I go from the negative to the ground to the positive, I'm getting 12 volts. Yeah, 11, 12 volts AC from there to ground. And I wasn't aware that the ground and neutral on these units were bonded. Let's check my other power station here. So we're gonna go in there into the line and into the ground over here. And I have the expected value, I'm sorry about the wires. So we're at 119, and then from there to ground. Yeah, so from line to ground is the 119, 120. The neutral to ground, there's potential between neutral to ground on both power stations. So I don't know if that's because they're connected together. Again, I'm sorry this video is so long, but I want to get everything in one shot. I'm going to turn that off, turn this off. Of course, it did give me the error message that one of the inverters had shut down. So we're going to disconnect this cable here completely. And then we are going to unplug the 240 volt combiner box. I'm going to power back up. That one's happy. And is this one happy? This one's happy. Okay, we're back running. Let's do that same test and see if there's some sort of short or bleed through in this unit between the neutral and ground, or line and ground. If that is what the problem is, if it is actually this box is what the engineer thinks may be bad, I should not see any voltage on either power station from the neutral to the ground. So we're gonna go back into the skinny terminal, which is the hot terminal, and then we are going to go to neutral to verify power, and we are at 119 volts. Going to ground, and I see 5 volts to ground on this unit from the hot wire. Let's see, I didn't do neutral to ground. So let's do neutral to ground. And neutral to ground, I still have 5 volts. Or do I? And let's see, let me turn my light on. And that is volts, not millivolts, so that's like 6, 7 volts. Go across here again, 120. And then go down to ground again. And then there's still 4 volts. I shouldn't see any power on that. So let's test this power station. So we're going to go from the neutral plug to the line, and accepted value of 119 to ground, 4 volts. And then we're going to go from the line side to ground and 4 volts. All right, we got to have a comparison. So I'm going to come over here to my wall outlet, and I'm going to plug in, and of course it's not going to fit because these are tamper resistant. We're going to force it in there anyway. It doesn't matter if I go to the next outlet up because they're all connected together. So do I have a connection? No, I do not have continuity. Oh, child-proofed outlets. Okay. Let me think. Where can I test that I don't have a child-proof outlet? Do I go outside or do I pull? I don't want to pull that panel off and I don't want to pause. All right, you guys are coming for a walk. We're going to go outside. There we go. All right, kids, don't try this at home. I am not a trained professional or stuntman. So if this goes horribly wrong, you'll never see this video, but I'm gonna go stick probes in something I know that doesn't have childproofing in it. Oh, what am I thinking about? My RV's hooked up. We'll just go check in my RV, because I know that's hooked up, and it's hooked up to AC, so I know none of these are childproof. All right. Are we still alive? We are alive. Okay, maybe today's not my day to get, let's see. All right, we actually got light to do this test. So we're gonna go in here and, yeah, I'm not touching that. I'm willing to bet that I have a breaker off. Man, we're doing all kinds of fun stuff today. All right. No trip breakers. That's not making any sense. Did I break my probe? Could have broke my probe. That is not making any sense. All right. There's a GFCI in the bathroom here, but I don't think it's connected, but it could be. All right, we're going to go in here, there, and there. Okay. So I have 120 volts from the neutral to the hot wire. So now I'm going to go to ground, and I expect to see that to ground because this is bonded. Okay, now we're going to go back into here, and now we're going to go from neutral to ground, and it should be nothing. Millivolts, 0.2 volts, which is what I would expect. Not actually 4 volts. So that's an alternate from the hot to the ground. And then that's the way it's supposed to go right there. Okay. So those are expected values. Turn off lights. Okay, so longest video I've done yet. there's my solar setup. There's the Starlink that blocks the solar partially through the day as we're getting the winter time here. It's raining. Let's go back into the garage and look at things one more time. I'm not sure that those values on the portable power station probably shouldn't be seeing 4 whole volts. And I'll tell you a little funny joke. So I got these 2 solar panels with a package for my RV to put in the roof of my RV, and the inlet box on the top of my RV, the wires came off inside that aero cover on the front. So the wires like fell down inside the RV at some point, so there's no continuity. So I never put those on the roof. Wired everything up and then realized they didn't work when they were on the roof. So I've been using those as a backup charging thing. But those panels are more expensive than the big panels out front that you guys just saw. So those 2 little panels that I showed you, those flexible ones, I know I'm all over the place in this video, but hey, you guys are still watching. Thank you. This is coming in right now from the main panel array, the 42 volts. This 11.5 is from those 2 panels I just showed you. And somehow this thing thinks, well, okay, I got 4 watts coming in from the big panels out back. And that's the further away array that has 3 panels. This one over here has 6 in a series parallel configuration. And I'm only sitting at 38, 37 volts. So that it's not doing any charging whatsoever. So I have all 6 panels coming here, and then these inlets are linked. So when I do eventually install it, if it is a single charge controller, it's going to have 1 string per controller. This was just a temporary setup for off-grid testing. Anyway, thank you guys so much for watching. Please, if you've watched this far, you probably should subscribe. Y'all have a great evening. Thanks.